So, to obtain the Pareto curve, we need to obtain first points A and B and then anywhere in between. And to get point A, what we have to do is to solve our linear programming twice. First, we maximize our return and get our max. We forget about the reach for a while, and then we get this value here that gives us the limit beyond which we cannot go. And then we solve a second time. And in that case, we add a constraint that imposes that the return we are getting is at least R max. So we are not allowing the model to find solutions, but within this vertical line. And then we want to minimize risk. So we want to descend down this line until we get to point A. If we want to get B, we will do the same. We solve first, minimizing risk, and get this K min so that we know exactly where is the limit, where beyond which we cannot go, we cannot find solutions with less risk, and then we solve a second time. We make sure that we don't have a risk larger than the one we got, okay, and we maximize our return. So we move in this line trying to approach the maximum return, which is point V. And finally, we can get any other solution. And since now we know the values for the maximum return and the maximum return we can get given the minimum risk and the minimum risk and the minimum risk we can get for the minimum for the maximum return, we know these segments here. We can explore them in two ways. One is to bound the risk, okay? So we set a horizontal line and we don't allow the model to go below it, and then we try to maximize our return, okay? Imagine we've set our, let's use green again. Imagine we've set that, okay, this is our acceptable level of risk. And now when we have bounded this, we are excluding solutions that are below this line. And that is using a constraint similar to this one here, but instead of using k-min, we would use some other value. And then what we do is to maximize our return, and we would move to the right till we find this point here. Okay, if we change the value for k in several locations, we can get different points in our curve. Or we could do the opposite. I'm going to use now color. No, I cannot change color anyways. I want to optimize return and sorry, I want to bound return. So imagine that we want to obtain a return which is at least, let's say, as good as this here. Okay, so we are not allowing the model to explore solutions here, and we want to minimize risk. Okay, and we can get this point here, and so on. That is the way to proceed to get different points along this curve, and eventually give them to a decision maker to make the best decision according to the extra information he or she might have.